Good evening, students. Today's topic is your measurements. Last class, I have given you the idea about physical quantities. Let me brief you that one. Physical quantities are classified into two groups. One is your fundamental, second one is your derived. Similarly, basing on the physical quantities, units also we have divided into two groups, your fundamental units and derived units. For our calculation purpose, I forgot to explain that two supplementary units are there, and that supplementary units, one for your plane angle and another for your solid angle. Plane angle, for plane angle your unit is radian, and for your solid angle the unit is steradian. Clear? Solid angle, actually it is, we can say it's a three-dimensional view of your normal angle. Clear? So let us come to our topic, that is your measurements. See, measurements is taking a very important role in our physics, because that day I have already told you, without calculation physics has no meaning. Calculation means not like that we will calculate, we will measure, and in that measurement we need some calculations. Clear? So basically our measurements are of two types, direct and indirect measurements. So the simple difference is, direct measurement is what? Like we can take the instrument and measure whatever physical quantity we want. That kind of measurement is called direct measurement. Simple example, suppose someone will ask you to measure the length of this marker. You take your centimeter scale and compare the length with the centimeter scale, you will find its length. Clear? That kind of measurement is called your direct measurement. In the same way, if someone will ask you to calculate the distance of sun from earth or the arm of our galaxy, so it is very difficult for us to measure the length directly. Clear? Or suppose someone will ask you to calculate the the amount of water contained in an ocean or amount of water contained in a pool. So that will be very difficult for us if you go in a direct measurement. That's why every time this method is not sufficient, or it is not, we cannot use this method. So there are so many indirect methods are there. So some techniques that is already known to you that I have pointed here, like radar technique, sonar technique, spectroscopic technique, triangulation method, parallax. These are some common methods. So apart from this, there are n number of methods, because there are n number of physical quantity, and all the physical quantities cannot be accessibly directly measured, or we cannot measure them directly. That's why some indirect techniques are being used here. So let me explain you one or two, because all the techniques that is impossible here to teach you. So let me tell you how the indirect techniques are there. There are two, one technique is there, that is your parallax, that is there in your syllabus. So let us understand this. Apart from that, let use this triangulation method that is already you have learned, that is your height and distance, you can say, for inaccessible objects. Let's say you are intending to calculate the height of a mountain. So by this method you can calculate the height of a mountain, but approximate, not exactly. How? Suppose, let's say this is the mountain AB, and this is the foot of the mountain. You walk to a point C from the foot and you measure the distance D. Now from this you observe the foot and rotate your head and observe the peak of the mountain. So your head will move some angle theta, or by some similarity method you can find out this theta. Yes, by measuring some instruments, taking some instruments help of compass or something, you can measure the value of your theta. If you can measure the value of this theta, you can find out height. How? It is a right angle triangle, because almost all the mountains are there vertical. So this angle is 90 degrees, so it's a right angle triangle. And in that triangle you can find out the value of tan theta. Tan theta is equal to your this AB by BC, that is h by d, and you can calculate h. H is equal to d into tan theta. So by knowing this theta, you can find out the value of tan theta, and you have calculated this d. So h is equal to d tan theta. So you can find out the height of a mountain by this indirect method. This is called your triangulation method. This is one type. Similarly, you can use parallax method. Let me explain you what is the meaning of a parallax. Parallax is what? Suppose you hold a pencil in front of you. Yes, you hold a pencil in front of you. Close one of your eye and see the pencil. Clear? Now open this eye and close this one. You do it 2 to 3 times. You repeat this 2 to 3 times. You will find there is a shifting in the position of your marker. Clear? This is called your parallax. This phenomena is called your parallax. By using this method, we can calculate some very large distances. Clear? Now, how? Let us see here. Suppose, let's say this is the point, this is the object you are observing. A and B are two different point of observations. You are observing the same object from two different observation points. The distance between two observation point, it is called your basis. Just the example, the separation gap or the gap between your eye, that is called your basis. One example. So between this the distance between A and B, this is small b, which is called your basis, and this is the object you are observing. So the angle made at the object by the two observation point, this theta, is called your parallax angle. Clear? And see, this method is we can calculate the value, or it's an approximate method. We can get an exact value. If the value of theta is very, very small, so this method will be, that accuracy will be more. And now you see, if the value of theta is very, very small, then theta we can take b by d, means this by this. Clear? If theta will be small, then theta is equal to this length divided by your d. Got? Because if you join this, it is the A and B, and by taking this OA to be your radius and O to be your center, if you join, means you will find AB will be your arc. So in that case, we know theta is equal to arc by radius. If theta is small, then the length of the arc and your length of this chord must they will be equal. That's why if theta will be small, so your in this method will be accurate. So here theta is equal to b by d, and your d is equal to b by theta. So this method is applicable if theta is small, and remember, theta is all the time, it is measured in radian. Clear? The unit of your angle what we are using under your SI system. Clear? And the conversion factor, that is already you have acquainted the your unit of angle is degree. So let us take the conversion factor here. We can take the unit of angle as radian. We can take one unit radian. Sometimes you will find minute. Minute is also another unit, also second. Clear? Now you see, the conversion factor is here. Pi radian is equal to 180 degree, and 1 degree is how much? Pi by 180 radian. Radian short form you can write RAD, or the symbol for radian is this. Clear? So pi by 180, pi is 3.14 by 180. If you calculate, you are going to get 1.745 into 10 to the power minus 2 radian. Clear? And if you use this two conversion factor, like 1 degree is equal to 60 minutes, you can find 1 degree is equal to 60 minutes, means 60 minute is equal to 1 degree, and we know 1 degree is equal to this much radian. So you can write that is 1.745 into 10 to the power minus 2 radian. So the 60 minute is equal to this much radian. So 1 minute is how much? So 1 minute will be 1.745 into 10 to the power minus 2 by 60 radian. So if you calculate, you are going to get this thing, 2.91 into 10 to the power minus 4 radian. Clear? So if you calculate it, you are going to get that value. Similarly, we know 1 minute is equal to 60 seconds. See, the symbol of minute, you can write like just like this, symbol here. This is the symbol of minute. So 1 minute is equal to this much radian. And 60 seconds. For second, you can take double, like this mark will be this one is the symbol of your second. So 60 second is equal to your 2.91 into 10 to the power minus 4 radian. Got? Means your 1 minute is equal to this much radian. This is 2.91 10 to the power minus 4. That's why I have written. So means 1 second will be 2.91 into 10 to the power minus 4 radian divided by 60, and the value it becomes 4.85 into 10 to the power minus 6 radian. 1 second. So you must remember this figure and this figure, so that you can put it directly in some numericals. Clear? And also this figure. Got? So while taking the, remember, while this is the most important point here, while taking the value of theta all the time is in radian. Got? So students, now let us solve one question related to your parallax. The question is like this. The moon is observed from two diametrically opposite points A and B on Earth. The angle theta subtended at the moon by the two observation point is 1 degree 54 minute. Compute the distance of the moon from the Earth. Given data is radius of Earth is 6.4 into 10 to the power 6 meter. So the basic thing is you have to understand the question. Here the moon is observed from two diametrically opposite points A and B on Earth. Got? Suppose you are here, it is Earth, and you are observing moon from two diametrically opposite points. So you draw one diameter. Let's say this is the diameter on Earth as it is mentioned here. Let's say this point is A, this point is B, and you are observing the moon. Let's say the moon is here, because as you are observing here, the angle theta is subtended at the moon at this two observation point. That's why I took the moon to be here. So you join. Clear? Means in this case, this angle is your theta. Means the distance between A and B, I can take it to be your basis, and this to be your D. Clear? So from the diagram it is clear. Now we can use the formula. Theta is given, it is 1 degree 54 minute. Since degree and minute both are combined, so either we have to convert it into degree or into minute. So 1 degree 54 minute is equal to how much? 1 degree is 60 minute plus 54 minute. So which is how much? So 114 minute. Clear? So now we can use this formula. Theta is equal to B by D, which implies your D is equal to B by theta, and B is your basis. Basis is what? A and B diametrically opposite point, so means it is the diameter of the Earth. As the radius of Earth is given, diameter will be twice of it. So B is equal to how much? So data given, B is equal to 2 into 6.4 into 10 to the power 6 meter. So which is 12.8 into 10 to the power 6 meter. Now you can put the value over here, means B, that is 12.8 into 10 to the power 6 divided by your theta. Theta is how much? Theta is 114 minute. Now you can convert this minute into radian. Got it? So you can calculate the value.